This video will look at the effect of sample size on the accuracy of the Lincoln-Peterson index. This is the second video looking at the capture-mark-recapture process of estimating population size. This bag of beans represents the population that we wish to estimate the size of. These are our containers for sampling our population. So we're going to get straight into it using our smallest sampling pot first. What we do is fairly straightforward. We simply take a sample from the population using our sampling pot and place the individuals into our tray. These individuals all need to be marked, and we're simply going to use some green spray paint to do that. We need to make sure that they are all fully covered so that they are easy to spot at a later date. And now we have to wait for the paint to dry. After being counted and marked, we end up with our first piece of data, and that is that M equals 91. From here, the beans are placed back into the population and given plenty of time to mix thoroughly. We will simulate this mixing process by simply sealing and shaking the bag. Using the same size sampling pot, we will now take our second sample. We need to count the total number of individuals in this second sample, and this is represented by the letter C. And we also need to count the number of individuals in the second sample that were already marked green. These represent our recaptures and are the letter R. Now that we have counted all of the individuals, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105, 107, and 10, 22 individuals that were already caught, we can complete our population estimate because we have all of the data. First, we return the individuals back to the population. The mathematical formula that we use says that the number of individuals in the population, N, is the same as the number of individuals in our first catch multiplied by the number of individuals in our second catch divided by the number of individuals that were recaptures. So we substitute in our data where M is 91, C, which is our second catch, is 107, and the recaptures is 22. Simply use a calculator to calculate your values. And this provides us with a population estimate of 442.59 individuals. We will now repeat this process, but this time with a larger sampling pot. So here is our sample. We're going straight to our largest sampling pot. The process is the same as before. We simply take a sample using the sampling pot, which we will then mark and count. Now that we have counted and marked the individuals, we have our value for M, which is 191. We can now return these marked individuals back to the population, and we can allow them to mix thoroughly with the wild population before preparing to take our second sample. Once again, we simulate the mixing process by simply shaking the bag. Remember, mixing is an important part to make sure that we don't end up collecting an unusually high number of marked individuals in our second sample. So we use our sample pot to take our second sample and count the number of individuals C and the number of recaptures. Having completed our second capture, we are now able to start our calculation, where N, the number of individuals, is equal to M, the number of individuals in the first capture, multiplied by C, the number of individuals in the second capture, divided by R, the number of individuals that were recaught. So we substitute in our data, simply use a calculator to complete the final process. And this gives us an estimate of 414.51 individuals. To analyse how the size of the sample affects our population estimate. With our small sample pot, we estimated the population size to be 442.59 individuals, whereas with the large sample pot, it was estimated at 414.51 individuals. In reality, both populations of beans contained 400 individuals. So whilst both answers seem quite accurate, we can take this a little bit further and start to calculate the percentage error of these values. Percentage error is just used to gauge how closely our measured value, in this case our estimate, is to the true value of the population size. So we simply take the estimate, we subtract from it the actual value, divide that by the actual value, and then times it by 100. So here is the calculation for the small sample pot. We take our estimate, 442.59, subtract 400, which is the actual value, divide by 400 and times by 100. That gives us a percentage error of 10.65%. We do the same calculation for our large sample pot, which is 414.51 individuals, minus 400, divided by 400 and times by 100, and we get a percentage error of 3.63. The key learning then is that the bigger the sample, the more accurate the estimate of population size. I hope this video was useful to you. Good luck with your assessment calculations.